Welcome, Junior Detectives. Are you ready to crack the real-life mystery? Let's travel back to 1993. A young girl escaped from her abductor, and the police found the suspect's car. However, her fingerprints were nowhere to be found inside the car. So why did this happen? Well, kids' fingerprints are made of lighter and more volatile oils that evaporate faster than adult prints. This made the prints disappear more quicker. Even though the invisible prints puzzled investigators, they still solved the case by matching fibers from the girl's nightgown to those inside the car. So even without fingerprints, clues can also be found.
Next is making the invisible visible. So when someone touches a surface, they will leave behind a ghost trace or invisible fingerprints called latent prints. So forensic experts use chemistry to turn these invisible clues into visible evidence. Here is how. So first is dusting powder method. So imagine Detective Fairy Dust. A fine black powder, often made of carbon, stick to sweat left in fingerprints ridges. This reveals the fingerprints pattern. For example, in many crime shows, you will see detectives dusting the surfaces and finding prints that glow under the UV light. For second is iodine method. When iodine is heated, it turns into a gas that sticks to oils and fats in fingerprints. This creates a yellow-brown print that is perfect for paper on cardboard surfaces. And this method has been used in the old cases where paper evidence was important. For the third one is ninhydrin method. This one for the paper trail. Ninhydrin reacts with amino acids in sweat to form a purple color called Ruhemann's purple. Even fingerprints that are years old can reappear with some heat and chemistry.
Now, let's talk about DNA fingerprints. Think of your DNA like a unique barcode or a secret code that only you have. No two people, except identical twins, that share the same DNA patterns. DNA fingerprint helps scientists solve crimes by matching blood or hair left at the crime scene. It can also find family relationships, like when people want to know if they are related. So how does DNA fingerprinting actually work? Well, it's kind of like finding someone's unique code. First, you start by collecting a sample, like some blood, spit, or even strand of a hair. Then scientists will take the DNA out of the cells in that sample. After that, they cut the DNA into smaller pieces using enzymes. And then these pieces are placed into a gel, and electricity is run through it. And the smaller piece will move faster, so they spread out based on their size. And next, the pattern is transferred into a special sheet, and a probe is added that sticks only to a certain part of the DNA. And finally, they take an X-ray photo that shows the DNA patterns, kind of like a barcode that's unique to each person.
What chemical reactions are involved? Here are some cool chemistry tricks that help reveal fingerprints. So first is ninhydrin reaction. So the chemical principle is ninhydrin reacts with amino acid in sweat. The reaction is amino acid plus with ninhydrin, and we will get our Ruhemann's purple. And it used for porous surface like paper. Next is cyanoacrylate filming. The chemical principle is cyanoacrylate vapors polymerize on fingerprints residues. The reaction is cyanoacrylate monomers plus with moisture prints residues, and we will get white polymer. It's used for non-porous like plastic or glass. And the last one is silver nitrate method. The chemical principle is silver nitrate reacts with chloride ions in sweat to form a silver chloride. And the reaction reaction is AgNO3 plus with NaCl, and we will get AgCl plus with NaNO3.
Now, let's talking about real-world applications. Fingerprint science isn't just for a detective, but it is everywhere. Well, for the first one, in medical imaging doctors use like endoscope that bend light inside the body without surgeries. It's like light bending can make a fingerprint disappear. Next, the security. Special dome cameras use a curved glass to get better views and keep the places safe. Well, for the last example, in military tech, scientists are working on invisibility cloaks materials that bend lights around the object to hide them, just like disappearing fingerprints hide the clues. So, fingerprint science help the crime solving, health, security, and even a secret spy gear. Whatever, there's something we need to watch out for. People might get confused without clear explanations. Optical illusions could be misused for spying, and some chemicals used in the lab need to be careful handling.
Now is the effect on people. Some fingerprint chemical can affect human health, especially if they are not used with proper care and protection. So let's take a closer look at two common ones. First is carbon black powders. These are fine black dust that used to leave fingerprints or smooth surface. If someone breathes it by accident, it can irritate the nose, throat, and especially the lung. This might lead to coughing, sneezing, or difficulty breathing. People with asthma or other breathing problems could have stronger reaction. Also, if it gets on your skin or in your eyes, it might cause minor irritation or itching. Second is iodine vapors. Iodine is often used to detect prints on paper. It turns into a gas that sticks to oily part of fingerprints. However, breathing it too much iodine vapor can be harmful. It may cause headache, dizziness, coughing, and throat irritation. If it touches the skin, it might cause redness or the burning feeling. In high doses, it can even damage your lung or eyes. That's why it's important to use iodine in well-protected area and wear safety equipment like gloves or goggles. So now this is the effect on the environment. Now let's talk about how fingerprint powder and chemical can harm the environment if they are not disposed of properly or used too much. First is same carbon black powder. Since this powder is very light, it can easily spread into the air and land on soil or in the water. When it settles on plants, it might block sunlight from reaching their leaf, which make it harder for the plant to grow. If it fall into the lake, river, or ocean, it can pollute the water and harm fish, frogs, and other animals. It might even be eaten by small creatures, which can spread the pollution through the food chain. Over time, this can affect ecosystem and make the environment unhealthy. Second is iodine vapor. When iodine becomes a gas, it spreads into the air and adds to air pollution. If used too often or released in large amounts, it can settle on plants or nearby soil. This can damage leaves or affect how well the plant grows. Also, small animals that live near lab or places where iodine is used could breathe it in and also absorb it through their skin. Even though iodine is natural, too much of it in the air or water can be dangerous to both animals and the environment.
Fingerprints may seem small and simple, but there's a lot of amazing science behind finding a hidden clues and solve mysteries. From case disappearing prints to high-tech invisibility clocks, the world of fingerprints is full of surprises. Thanks for joining our detective adventure today.